Okay, right angle triangle, measurements given. We're asked to calculate angle BAC. That's this one here. We need to bring out the SOHCAHTOA. I'm going to label the important sides. So this is my angle. This is the opposite, because it's opposite the angle. And this is the adjacent. That didn't look very much like an O, so I'm just going to do that again. And the other one would be the hypotenuse, which I could label, but I know the opposite and I know the adjacent. So I'm going to call the angle X, and I can write, what can I use then? I'm going to be using this one because I know O and I know A. So this is basically abbreviation for the fact that tan X is equal to the opposite over the adjacent, or in this case, 37 over 20. Remember, trigonometry is basically saying if you've got this infinite number of similar triangles, and as you double the lengths, for example, the angles don't change, but the sides will change in the same ratio. They just both be doubled. But that basically gives us a single ratio for the opposite over the adjacent. If I double this to make it 74 and 40, I'll get the same thing when I divide by the opposite by the adjacent. And we call this thing tan x, and we can list the values, and then we can basically work back. Well, in some cases we can use the angle on the side to calculate another side. In this case, we can work back to get the angle. So we're going to do the opposite of tan, which is inverse tan of 37 over 20, and that will give us the angle we're interested in. $61.60. I'll round it to three significant figures, 61.6.